Hello, welcome to STEM School. In this lesson, we are going to go through Math Gauss Contest selected problems.
Okay, so first 11. In the sequence 1, 3, 4, 7, each number beginning with a 4 is the sum of the two numbers before it. This means that the next number in the sequence is 4 plus 7 is 11. The smallest number greater than 100 that appears in the sequence is. So we need to list all the numbers in the sequence, because we need to find the smallest number which greater than 100. Okay, so 1, 3, 4, 7, 11 is the number they listed for us. So next, which will be 11 plus 7, 18. 18 plus 11, 29. 29 plus 18, 47. 47 plus 29, 76. 76 plus 47, 123. Okay, so the smallest number but greater than 100, 127. 123, right? Okay, so next, number 12, the number 385 has the 3 prime factors. The sum of these prime factor is. So it's easy to see 385 is divisible by 5 because it ends with 5. Okay, so which give us the quotient 77. So 77 is divisible by 7, which give us 11. So the 3 prime factors for 385 is 5, 7, and 11. So they want us to find their sum. So we need to add them together, which is 12 plus 11, 23. Answer is D. Okay. So 13, trapezoid ABCD can be divided into 3 equilateral triangles. So if the perimeter of the trapezoid is equal to 840, what's the length of AB? Okay, so for this one, first we divide the trapezoid into 3 equilateral triangles. We find the midpoint of CD, can put it as E. So then we connect AE and BE, so which give us 3 equilateral triangles. So equilateral triangles will have the same length, right? So we can set up X is X. So AD is also X, DE is X, CE is X, CB is X. So how many X in total we have for the trapezoid? 5X, right? So then the 5X equals to the perimeter of the trapezoid, which is 840. So the value of the X is 168 centimeter. So the answer is C. Okay. So next 14, a container of ice cream can make 6 cones and or it can make 4 sundaes. If 5 such containers of ice cream are used to make 12 cones, what is the greatest number of the sundaes that can be made with the ice cream that remains? Okay, so the number of the container, the number of the cone, the number of the sundae. Okay, so one container can make 6 cones, or let's write another. One container can make 6 cones. One container also can make 4 sundaes. Now we have 12 cones with 5 containers. So if we have 2 containers, we can make 12 cones. But now we have 5 containers, which means we left 3 containers. So 3 containers, if we use all of them to make sundaes, which will be 3 times 4, 12 Sundays. So the answer is C. We will have 12 Sundays. Okay. So next, when a positive integer n is divided by 10, the remainder is 8. When n is divided by 5, the remainder will be. Okay. So for this one, if n divided by 10, it will be some quotient and the remainder is 8. So the number we can confirm those numbers like for example the numbers that are equal to 8 more than a multiple of 10. For example, like 8, 18, 28, or 38, something like that. So if those numbers are divided by 5, so the remainder will be 3, will all be 3, right? So the answer is D. Next, a block of wood in the shape of rectangular prism has a length 4, width 4, and height 7. A cylindrical hole with radius 1 centimeter is drilled through the center as shown to the nearest centimeter cubed. What is the volume of the block of wood after the hole is drilled? Okay, so they want to make the question easier, so they give us the volume of a cylinder with radius r and height h is pi r squared h. Okay, so first we need to find the volume of the block of wood. Which is 4 times 4 times 7, length times width times height, right? So length times width times height. So it's 112 centimeter cubed. And then the cylinder hole, we can find the radius. It's pi r squared h. So the volume of that will be pi r is 1, right? So pi r squared height is the same thing as 7. So the answer is 7 pi centimeter cubed. What did they ask us? The volume of the block wood after the hole drilled, so which will be 112 minus 7 pi, which is pi is 3.17. We can calculate it. It should be approximate 90.09. So the volume left is 90 centimeter cubed. Number 17. The Gauss factory assembled robots. Each robot comes in one of 3 colors: red, blue, and or green. Each robot also has a number stamped on its head, 1 to 4. The nth robot assembled is the first robot to have the same color and the same number as the previous assembled robot. What is the greatest possible value of n? Okay. So we have 3 different colors and 4 different numbers, right? So how many different types in this case? 3 times 4, which is 12. 12 different kinds of robots with different colors and different numbers, right? So the next one, the greatest possible of value n is 13, because they want us the nth robot sample is the first robot to have the same color and the same number, right? So it's 13, the greatest possible value. Number 18, a circular spinner is divided into 5 equal sections. An arrow is attached to the center of the spinner and its position as shown. The arrow is spun clockwise and it stops in the section labeled D. Which of the following could have been the angle of the rotation? So the circle is 360 degrees, right? Divided by 5 equal sections, so each section is 72 degrees. Okay? It's clockwise, and it stops in the section labeled D, which means it has go through A, B, C sections. It has run 3 sections already, so at least greater than 216 degrees. And should be lies, it's in the section D, so it's 288 degrees. So in this case, it should be greater than 216, but smaller than 288. But look at our answer. It doesn't have that, right? So which means it rotates more than 1 clockwise, right? So in this case, the circle is 360. We can use 216 plus 360, which is 576, and 288 also plus 360, which is 648 degrees. So now let's go back to see our answer, which one is in this range. So C, 630. Okay. So let's see last 2 questions. So 3 different integers in the list have a means average of 50 and a range of 14. Range is the greatest number minus the smallest number, right? What is the smallest possible integer in the list? So we have 3 different integers. So their sum, we can find their sum first, right? So their sum should be 3 times 50, 150. Okay, so their sum is 150, and the greatest one minus the greatest one minus the smallest one. We can find the smallest possible integer in the list. We can substitute the answers. So first we find the sum is 150. So let's see if 69 workable. So 69 plus 14, if 39 is the smallest, so the greatest will be 39 plus 14, which is 53. So 53, we use the sum 150 minus 53 minus 39, which give us 58. And 58 is not in the middle, so 39 is not our answer. Next, we can try 40, right? So 40 plus 14 is 44. Sorry, 54. 54. And we use 150 minus 40 minus 54. Which give us 56. So 56 is also not in the middle, no. Next, we can try 41. So 41 plus 14, which is 55. So 150 minus 55 minus 41, which give us 54. So 54 lies in the middle. So the three numbers should be 41, 54, and 55. Answer is E. So next, Kira has a box containing 3 different types of fruit: apple, pears, and bananas. If in the box 21 pieces of fruit are not apple, 25 pieces fruit are not pears, and 28 pieces of fruit are not bananas, how many pieces of fruit are in the box? Interesting. So since 21 pieces of fruit are not apples, so the number of pears added the number of banana is 21. Okay, so apple we can use as A, pear we use as P, banana we use as B. So P plus B is 21. And 25 pieces of fruit are not pears, which means A plus B is 25. And the next 28 is not bananas, which means A plus P is 28. So how many pieces fruit are in the box? So we can add all these numbers together, which is 2P plus B plus A. Add the right side together, which is 74. So P plus B plus A is 74 divided by 2, which is 37. So answer is D.
That's everything for today's lesson. Please click like if you like this video and subscribe my channel. Thank you.